In this video, we will be discussing what to do when we have negative exponents. So in order to understand negative exponents a little bit better, we're going to quickly review the shortcut for what to do when we're dividing terms with exponents. So remember that if the bases are the same and you're dividing, the first thing you do is you reduce any coefficients, and then you would subtract the exponents. That's for all division problems. So that's what we did a couple days ago. If your exponent is 0, remember that you can just cancel it out and it would equal 1. So for negative exponent, basically an exponent tells us how many times to multiply by the base, where a negative exponent tells us how many times to divide by a base. So to remove the negative exponent, we can always flip to the reciprocal. Remember that a reciprocal is when you reverse. So let's just say you have 1 over x to the negative third power. To get rid of the negative exponent, we could just take the reciprocal, which would be, and make it a positive exponent, which would be x to the third power over 1, or we can just write it as x to the third power. So what actually does x to the negative 5 power mean? Well, that's the same thing as taking the reciprocal, so making it 1 over x to the positive 5 power. And 1 over x to the positive 5 power is the same thing as 1 over x times 1 over x times 1 over x times 1 over x times 1 over x. So basically multiplying that fraction by itself 5 times. So therefore, what does 1 over x to the negative 5th power mean? Well, that would be the same thing as the reciprocal and making it a positive exponent. So that would be the same thing as just x to the positive 5 power, which remember was x times x 5 times. So let's practice getting rid of negative exponents with some of the easier examples that we have below. So x to the negative third power, I can't leave my answer like this, so I would take the reciprocal, so move x into the denominator and make the exponent a positive 3, and then if there's nothing in the numerator, we just put a 1 there. So that would be equal to 1 over x to the positive third power. Same thing with a to the negative first power. We put a in the denominator to take the reciprocal, and then it would become a positive 1. I don't have to write the 1 exponent, but I can. And then again, since there's nothing in the numerator, we just put a 1 there. And then for this third example, we're going to take the reciprocal, but this time we have to move b into the numerator and make it a positive 2. And there's nothing in the denominator, so you can either put over 1 or you can just leave it as b to the second power. So let's just kind of recap what we're going to be doing today. So we're going to follow the 3 steps below for these multiplication and division problems. Step 1 is always simplify the coefficients. Then step 2 is you're going to follow the product and quotient properties. Remember that for the product property, you add the exponents when you're multiplying. And then for the quotient property, you subtract the exponents when you're multiplying. Then the very last thing you do is if you have any negative exponents in your final answer, you flip to the reciprocal of any base with a negative exponent. Okay, so we're going to start off with some easy examples and then get into some of the more challenging ones. So for this first example, this would be a multiplication problem. And so remember, for multiplication problems, you add the exponents. And since there's only one coefficient, we're just going to bring down that 7. And then we're going to add -3 and -8 together to get x to the -11th power. And then we can't leave our fraction like this because you can never have a negative exponent in your final answer. So we're going to keep 7 in the numerator, but we're going to move the x into the denominator and make that a positive 11. So final answer would be 7 over x to the 11th power. In the next example, it's a division problem. So we're going to reduce 4 over 2, and that just equals 2. And then subtract the exponents. But be careful, when you do -5 minus -2, a double negative makes a positive. So you would get a to the -3rd power. And then I can't leave my answer like this because it has a negative exponent. So keep 2 in the numerator and move a into the denominator and make the exponent +3. So final answer would be 2 over a to the +3rd power. Okay, let's try the examples on the next page. Starting with problem number 1, this is a multiplication problem. So we're just going to add the exponents to get g to the 2nd power. And this would be our final answer. In example 2, we just can't have that negative exponent, so we need to move c into the denominator. So keep 4 in the numerator, and then c would go to the denominator, and the exponent would become a +4. In number 3, it's a division problem, but we can't subtract the -9 and the -3 because we have an m and an n, and those are different bases. So we just need to get rid of the negative exponent. So the n needs to come to the numerator, the m needs to come into the denominator. So I would have n to the +3rd power on top, and then m to the +9th power on the bottom. In example 4, this is a multiplication problem. So multiply the coefficients. 3 times 2 is 6, and then add the exponents. So 4 plus -3 is just c to the 1st power. So 6c or 6c to the 1st. In problem number 5, we just have to move the negative exponent into the numerator. So 2 would stay, and then a to the 4th would go next to it. That's the final answer. For number 6, this is a multiplication problem. So we just bring down -4 since that's the only coefficient. And then we're going to add our exponents together. So I get y to the -3rd power. I can't leave my answer like this because I have a negative exponent. So the y needs to go into the denominator, and it would become a +3. And -4 is just going to stay in your numerator. So -4 over y to the 3rd power. Next problem, problem number 7, is a division problem. So we're going to subtract the exponents. Be careful, -2 minus -5 would give us x to the -3rd power. And then 4 minus -3 would give us y to the +7 power. We can't leave our answer like this with the negative exponent, so you just have to move the x into the denominator. So y to the 7th stays in the numerator, and then x to the 3rd goes into the denominator. Final answer. In example 8, this is a division problem. So we're going to reduce 6 over 18 to 1 over 3, and then subtract the exponents. Remember that when you're subtracting, you always put your exponent in the numerator. So we're going to do 6 minus -2, which would give us x to the 8th power. And that would be our final answer. In example 9, again, we have division again. So we're going to reduce negative 2 over 6 to negative 1 over 3, and then subtract the exponents. And we always put it in the numerator to start. So negative 10 minus 4 is m to the negative 14th power. Then we're going to move the m into the denominator since it's a negative exponent. So negative 1 stays in the numerator, and then I have 3m to the positive 14th power in my denominator. Next example is multiplication. For multiplication, we need to add the exponents. So 3 plus 5 gives me x to the 8th power. And then negative 2 plus negative 3 is y to the negative 5th power. I can't leave my answer like this because I have a negative exponent, so y needs to go into the denominator, and then x is going to stay in the numerator. So I would get x to the 8th over y to the 5th. In example 11, it's a division problem, so let's reduce 24 over 4, which is equal to 6. Since the a's have the same exponent, we can just cancel them out. The b in the denominator has an exponent of 1, so we need to subtract. 7 minus 1 is b to the 6th power. So I get 6b to the 6th power. In example 12, this is a division problem, so I'm going to reduce the coefficients. 2 over 4 reduces to 1/2, and then I'm going to subtract the exponents. So for the x's, it would be 3 minus negative 1, so x to the positive 4. For the y's, it's negative 6 minus 3, so I get y to the negative 9th power. Again, I can't leave my answer like this because I have a negative exponent. So x to the 4th is going to stay in the numerator, and then 2 will be in the denominator and bring down y and make it to the positive 9th power. So x to the 4th over 2y to the 9th power would be your final answer. All right, we got 3 more examples left to go. Example 13 is a multiplication problem. So we're going to multiply the coefficients. 3 times negative 5 is negative 15. And then add the exponents. So for the k's, I would do negative 4 plus negative 2. I get k to the negative 6th power. And then just bring that t down. It would just stay t to the negative 4th power. So because the other one doesn't have a t, that's okay. We just carry it down. Then I can't leave my answer like this because I have 2 negative exponents. So just keep negative 15 in your numerator and bring k into the denominator, make it a positive 6, and then t to the denominator and make that a positive 4. So for 13, I get negative 15 over k to the 6th, t to the 4th power. In example 14, this is division. So first I'm going to see if I can reduce negative 6 over 6. And actually I can just cancel those out because that just equals 1. Then I'm going to subtract exponents. So 3 minus 6 is m to the negative 3rd power. And then the ends are the same, so they also would cancel out. Now I can't leave my answer like this, so m needs to go into the denominator and become a positive 3. And since there's nothing in the numerator, we put a 1 there. So we get 1 over m to the 3rd power for number 14. For number 15, this is the most challenging one because I have a multiplication problem in the numerator. So first we're going to take care of the numerator and keep the denominator the same. So remember, we add exponents when we're multiplying. So let's add the a's together. So negative 5 plus 1 is a to the negative 4th power. Then we're going to add the b's together. Negative 5 and negative 4 is b to the negative 9th power. And then just bring down c to the 2nd power. Keep the denominator the same. So keep it as 2a to the negative 5, c to the 1st. And then it's a division problem. So we subtract exponents for division. So I'm going to keep 2 in the denominator since that's the only coefficient. And then for the a's, I have to do negative 4 minus negative 5. So I end up with a to the 1st power. And then b, I'm not going to subtract b. I'm just going to move it down and make it a positive 9 exponent. And then I'm going to subtract the c's. So 2 minus 1 is just c to the 1st power. So I get AC over 2B to the 9th. So hopefully you're getting the hang of this. It's the same thing we've been doing with the product property and quotient property. You just have to make sure that if you have a negative exponent in your answer, that you move it either to the numerator or the denominator to make it positive. Feel free to reach out to your teacher if you have any additional questions.